Hello everyone, welcome back to MA 1103 Business Mathematics 1, and today we will learn about the subchapter 6.3 of the Sets and Counting chapter, which is the multiplication principle. Okay, so what is this multiplication principle? So suppose we have two tasks, T1 and T2. And then we have m ways of performing the first task and n ways of performing the second task. And then if we want to perform the task T1 and then follow by the task T2, and then of course there will be m times n ways to perform those tasks. So this is what we call the multiplication principle. So let's see one example. If we have 3 trunk roads connects town A, town B, and then 2 trunk roads connect town B and town C. So now the question is, find the number of ways of which a journey from town A to town C via town B can be completed. So here of course we have town A, and then we have town B, and then we have town C. And then we have 3 ways, 3 trunk roads from A to B, and then we have 2 trunk roads from B to C. And then for the first trunk road from A to B, so the first one here, if we want to continue to C, we have 2 options, right? 2 options of trunk roads. So in that case we have 2 ways. And similar, if we take the second trunk roads from A to B, the second trunk roads from A to B, we have two possibilities to continue to town C. So another 2. And of course the last one we also have another 2 ways to continue to town C. So of course we have 3 times 2, and that's exactly how we get the multiplication principles. So if we want to use the multiplication principle to find the number of ways in which a journey from town A to town C via town B can be completed, of course it is just 3 times 2 equal to 6 ways. Okay, and then here we want to directly exhibiting all possible routes. Okay, so we just have to list what we have draw in the first question. So we have what? Say we have, this is the first road from A to B, so say AB1, AB2, and then AB3, and then we have BC1, and we have BC2. So all possible routes, the first one will be what? Will be AB1, and then continue with BC1. The second one will be AB1, continue with BC2. The third one will be AB2, continue with BC1, and then AB2, continue with BC2. The fifth one will be AB3, continue with BC1, and then the last one will be AB3, continue with BC2. So these are all the possible routes from town A to town B to town C via town B. All right. So the second example is about menu choices at a spaghetti bar. So we have here 6 varieties of pasta and 28 choices of sauce. Yeah, where so many choices for sauce. So if a customer want one variety of pasta and one kind of sauce, of course there will be how many combinations? Yeah, we can use the multiplication rules. There will be 6 variety of pasta times 28 sauce, and this is equal to what? Yeah, all right. So now we have here chairs in an auditorium, which is labeled by one capital letter followed by a positive integer at most 100. Yeah, how many chairs can be labeled differently? Okay, so here we have a label. Yeah, the first one labeled by capital letter, and then the second one is labeled by positive integer at most 100. Yeah, so the first one will be what? We choose one from how many capital letters? 26 capital letters. And then the second one we choose from 1 up to 100. Yeah, so there will be 100. Yeah, and then we will use multiplication principle, and then altogether we have 2600, so 2600 chairs that can be labeled differently. Okay, so there's also a multiplication principle of 2 tasks. Yeah, executed one after another. What if we have more than just 2 tasks? Yeah, so we have the first task, the second task, and then say so on until the mth task. Yeah, each of them can be performed in n1 ways, n2 ways, and in nm ways. Yeah, and then of course if we just think in the line of what we have done before for 2 tasks. Yeah, so the number of ways of performing the first task, second task, and so on until the m task in succession, it will be n1 times n2 times, and so on until nm. So now if we have a coin being tossed 3 times, and then we record the sequence of heads and tails, yeah, and then what is the number of possible outcomes in this activity? Yeah, so we toss a coin 3 times. This is the first toss, the second toss, and then the third toss. And then of course each of the toss has 2 possible outcomes. Yeah, so 2 possible outcomes, 2 possible outcomes, 2 possible outcomes. And then if we want to determine the number of possible outcomes of this activity, yeah, tossing the coin 3 times, of course, by using the generalized multiplication principle, we will have 2 times 2 times 2, which is equal to 8 possible outcomes. Yeah, and then we can use tree diagram to exhibit all the sequences here. Yeah, so say we have heads and tail. Yeah, this is the first toss. The second toss will be what? Will be again head and tail, head and tail. Yeah, and then here we have another head and tail, head and tail, head, tail, head, tail, head, tail, head, tail. Okay, so what are the result here? Yeah, what is the output? Yeah, the outcome. So we have the first one is H, 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 yeah, or head, and then we have head, head, tail, and then we have head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, head, and then tail, tail, tail. Yeah, so altogether we have 8 possible outcomes, and it has been counted by the generalized multiplication principle. Okay, so here are several exercises that you can try to solve by using the multiplication principle, either for just the two tasks or the generalized one. So you can pause and you can try to solve this. Okay, so that's it for this subchapter, and then thank you for your attention, and I'll see you again in the next video. Have a good day.